Kinetic energy is the energy stored in an object that is moving. So here we have two examples of objects with velocity: a hare that is running and a falling apple. Both of these objects hold kinetic energy due to their movement, and they gain kinetic energy as work is done to transfer other stores of energy into kinetic energy. But how can we tell how much kinetic energy an object has? Well, the kinetic energy of an object is determined by its mass and its speed. And we use speed instead of velocity as the energy is the same regardless of its direction. So the kinetic energy is equal to half times by the mass times by the speed squared. And in symbol form, that is EK is equal to half times by m times by v squared. The mass is measured in kilograms. The speed is measured in meters per second, and the kinetic energy is measured in joules. This formula will be given to you in an exam, but you need to be able to rearrange it and use it for problems. It's an extremely important equation that you should be very familiar with. Let's have a look at an example using this. A cricket ball of mass 0.2 kilograms is bowled and given 200 joules of kinetic energy. Calculate the speed of the cricket ball when bowled. Give your answer to two significant figures. So we can round our answers to a certain number of digits, and the number of significant figures are the number of digits in the value. So for step 1, let's write down the key information and check the units. The mass is equal to 0.2 kilograms. The kinetic energy is equal to 200 joules. And we want to calculate the speed. For step 2, let's rearrange the kinetic energy equation so that only v squared is on one side. So we can't use an equation triangle for this equation, but what we can do is rearrange it algebraically. We can start by multiplying both sides of the equation by 2 to give 2ek is equal to mv squared. So we must do the same action on both sides of the equation. We then need to divide each side of the equation by m to give 2ek divided by m is equal to v squared. And we can also swap around the two sides of the equation to give v squared is equal to 2ek divided by m. For step 3, let's take the square root of both sides of the equation to make speed the subject of the equation. So v is equal to the square root of 2ek divided by m. And it was really important to bring v squared to one side first, as we must take the square root of the whole side, not just one term. For step 4, we want to substitute the values into the rearranged equation to find the speed. So v is equal to 2 times by 200 joules divided by 0.2 kilograms, which equals 44.7213 meters per second. Then for step 5, we want to round the speed to two significant figures. So our first significant figure is 4, and our second significant figure is also 4. We then need to check the next value, which is 7, and round up the last significant figure. That gives us 45 meters per second.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!